Hey everybody, it's Damon. Crazy Logics on the forums and Crazy Logics 007 on YouTube. Back on this CT Sounds, and whatever I said in the last video, wrong. I did have the drivers in that we installed correctly. I put them all in, found a short, thought I had screwed it all up. I was tired, it was late, and I had everything right. I took this drawing off the drawing because I don't know where my other notebook is right now. Off that video, just to double check everything and what is the PNPs and NPNs and what it went in what place. And I was correct because I pulled all those drivers out. And I still, when I took a reading with my meter, I still had a short here, and so I had to flip it over and look and look and look, and underneath one of these terminals I had a hairline piece of solder wick, or not solder wick, but solder bridge, just the tiniest one, and that's what was throwing everything off. I thought I'd done a good job cleaning it. Nope, I did not. So I have stuck all these back in. I want to show you now. Those are all back in. I cleaned that little piece of thing, and I have replaced all the gate resistors with 47 ohm resistors. So up in the corner here, let's go right out. You should be able to see my scope, and I'm going to power this up. We should be able to see the little green light come on here. We don't have any FETs in it. We got the rectifiers and the power regulators, but if I turn the power on, you'll be able to see it power up. And so it powers up green right there. And now we can go on the pads of each one of these, and bam, there's the square wave. There's the square wave. It's good. Now I want to show you, I'm going to power it down. So here it is when it powers up, and watch how the square wave grows. Zoop. That's how it's supposed to. So we check every pad. That's good. That's good. That's good. That's good. And it's really easy for the circuit to drive this square wave to look really, really good when there's no FETs in it. Because the FETs have some capacitance to them, and that the more capacitance they have, the harder they are to turn on or off. And that is, let's see if I can grab that there. So what I want to point out, I get my little pointer and point it up here. If I zoom in some and I do this, so you can see this a little better. You can see a little tip right there that's jumping up a little bit, and then you can see it's not totally perfect coming down. Went the wrong way. But that is pretty dang close. Now those will get clamped by, mostly they would be worse than that if there wasn't a resistor and a capacitor across there, which helps clamp those low voltage spikes. Now it'll get a little worse looking once we put the FETs in, but I'm going to go ahead and put the FETs in. That should provide us power. So we've got technically 4 little power supplies here with 4 FETs each for each one. So 2 for switch to positive, negative, back and forth, back and forth, back and forth. And that will provide us power. That will go through the rectifiers, our rail caps. That'll give us rail voltage, plus that'll power these 2 inductors here that have the extra, no, it's this, one of these has got extra windings. This one right here, it's got these little extra windings, and this one's got it too, that provide voltage for the 2 voltage regulators that provide our plus and minus 15 volts for the audio input section over here. And then we have some regulators and stuff that provide 12 volts and 5 volts for our Class D switching board, which I've repaired, but I have not stuck back in yet because we're going to get the power up. We're going to check for good positive and negative rail. I've repaired that card. We'll do it in. I won't bore you with sticking in the FETs. They are 3205s, brand new, all matched, and we'll stick that in there. I'll bring you back when we go through and we're going to test for rail voltage, and I'll kind of show you how I do that. And this should get the power supply up and running on this CT Sounds. After we know that's good and we've checked the additional voltages on all these other regulators, and we know we've got correct voltages everywhere else, we'll add the card. Then we'll look for Class D switching on each side, and then once that's done, we will add in the 640 ends, which are these. They're all brand new. And I'll show you kind of how to identify high and low side, and then we'll add in a few, just the bare minimum, check it, make sure it's all working, and away we go. If you like lots of Class D repair stuff like this, go check out Sam's videos. It's Bear Vids on YouTube. He does tons of Class D. That's kind of what he specializes in. I like the Class AB a little more, but I do some Class D and stuff. So anyway, he does a really great explanation on how a Class D works. I'm probably going to do the same kind of thing, just do one with a Class AB, so that there's a kind of an explanation and shows the differences when I get a chance. But I'll bring you guys back whenever I've got the power supply fits in. Okay, we have the FETs all soldered in. Before doing anything else, we're going to give it a check. Notice the meter is going up. We're going to check it this way, and then we're going to check for shorts on any of the FETs. Anytime you solder this many FETs in, just going ahead and do the check for shorts. You will save yourself so much heartache and blown up stuff and everything. Ask me how I know. Alright, so that tested good. So we got it on continuity. So you will get a beep like that. Watch my meter. See how it says negative? That's actually where we charge those capacitors. And see, as it switches back over, it goes away. So that's okay. Sometimes you have to watch when you do continuity checks that you're not charging a cap. And big caps take longer to charge. So don't freak out if at first you get a beep. Just look at your meter and watch it. So now we're going to see we're charging it back the other way. Let it go away. Bam. That's okay. We're looking for actual solder whisker joints that are connecting these legs accidentally. After I soldered them, I also cleaned them with isopropyl alcohol and a toothbrush to clean all the flux residue and stuff, and to make it to where it's easier to see. Sometimes that also cleans away a little whisk of solder. Alright, they all look good. Means we should carefully spin this around. I add my power wire. Always look at your plates to make sure you know what power, remote, and ground is. Ground's on the outside on this one. Normally is on most, but I always double check. I work on so many different styles of amps. I don't specialize in any one thing necessarily. That I always just have to double check. If you was only working on certain ones, you'd probably get it and know what was going on and be okay. But not me. Alright, so we're going to turn on our little power supply. But it should have a hard time powering up. bench here. Okay, so we got the little power supply powered up. We can watch the little light over here. I'll try to shade it so it shows up a little better. Comes on. And we have stabilized our voltage, and we got about a 1.5 amp current draw. And I don't see anything smoking. So let's get the multimeter here. Okay, so I'm going to show you the gate now as it comes on. Notice it looks a little different with the FETs in place. Now there's a little overshoot on the pull down. There's a little bit of steps, not perfect, but in here I'll have to either switch it to AC, or that's how big. This is the gate. This is the back of the FET, or the center leg. And so you can go to the back of all the FETs. I had to put on AC instead of DC coupled so that we could see this whole thing. We're going to inspect all of them. Alright. And we can touch it with just one finger, because that way you're not making a ground point. None of them are hot. They're all cold. So let's go over here and look at these. They formed up good. Looks good. We're just looking for something that does not match the others, in case we was to happen to have a bad FET or a leaky FET. That looks pretty good. Alright. Now we can take our multimeter, and we're going to go to the rails here, and I'm not sure which is high side and which is low side, so we're going to put our voltage up on 200 volts. To be super safe, we could go 600, so let's just leave it in 600. I'm pretty sure this one does not make 600. So there's a couple different ways you can do this. The center taps of the output transformers can be a universal ground, but we also have the diodes here, 4 diodes on each side, and if you very carefully go across the 2 middle legs, you should see, oh nope, I lied. This is these are different kind of rectifiers. These are diodes both going in the same direction with a common center tap there. So it's going to be a little different. So it'd be just as easy then to find our high. But now we're at negative 87. So then these 1, 2, 3, 4, 5, that should be one side. 1, 2, 3, 4, 5. That should be a different side over here. So now we got negative 87, and we got 176 volts. Spin that around. 176 volts rail to rail on this amplifier. That's why you got to be careful. And just to show, that's how much voltage is still on there, and it's off. There is no power on the light. I'll turn off the power supply. That's how much voltage is still on this secondary that's stored in these caps on this rail. We still got 96 volts. This is how you shock and hurt yourself. This is how you give yourself a little pee in your underwear if you're not careful. And so that's why everybody says, you know, careful with mains voltage. Well, you get a 1,000, 2,000 watt amp. The voltage produced into the secondary for the rails, because it's a plus and minus voltage, there'll be a 0, and there'll be negative 78 and positive 78, and so those put together would make that 100 and whatever we seen, almost 200 volts. and then it takes a while to bleed off, especially with the FETs out. Now sometimes with the FETs in, it completes a nice little circuit and uses pull down resistors to help pull it down even faster, but not every amp. If you go back and watch my Machete series, where we fixed the I think the outputs on a little Machete amp, it did not have any extra pull down resistors, and so this voltage stayed up there for a long time, and I used a little draining resistor to help knock it down before I'd get close to it with my soldering iron or anything else. But we're still at 20 volts, but now we should be low enough. I'm just going ahead. Don't touch your leads like I did in that one video and did a little electro boom and hold them like a big idiot. Hold on to it there. Just let that resistor knock that last little 20 volts down. I got it stuck in there good. We'll take a measurement, and bam, the voltage is all the way down. Now it's safe to work on this. Now I'm going to have to find my drawing and stuff and figure out which ones, look at all these and figure out which ones are 5 volt. This is a 5, I can see it's a 7905, so that's a negative 5 volt. This is going to be a positive 5 volt, then probably these may be 12s, and they may be in parallel. These should be my 15s over here, so I will get ready to go through and I'll maybe even draw a little picture here, but you can also check some of it on these parts of the pads. So give me a second to get set up and we'll do the measurements here.